All right, so yes, help me welcome Imad Sousou from Intel.
Thanks, Jonathan. Hey, good morning. Okay, so thanks, Jonathan. And first thing I want to start with, I want to thank the foundation and Jonathan for putting this together. I think this is when Jonathan called up and about, hey, are you guys interested in sponsoring and participating? And it's unfortunate that we didn't know about this earlier because I think, you know, this is exactly the type of a summit and a conference that we need, and I'm hoping that this continues. And Jonathan, we would be gladly continue to support you in sponsoring and doing this, and you know, be more active, obviously, as we do. So the one thing that I'm not going to spend, I usually spend time on the merit of open source when I talk about things like this, and obviously here I'm not going to do that. We assume, you know, everything we talk about is open source. You know, given, particularly in this space, whether you're talking about the data center side of it, where 9 out of the top 10 data centers are running on open source and Linux and OpenStack and so on, and the same when you look on the client side, the vast majority, the billions of devices, again, it's all open source, so I'm not going to spend much time on that. What I will spend a bit of time on is talking about how we view things a bit at Intel, and just with some of it with my personal views on edge computing, which would, you know, we feel that it's really important to put that entire picture together instead of just data center and IoT and so on, the networking and so on. And I will spend time talking about a few of the projects that we're working on in this area. And actually, you know, I looked at how many projects, open source projects, that we at Intel, and probably mostly in my group, are working on that are relating or focused on some part of edge computing. And there's literally, we counted over 100 projects. So the projects that we chose that, hey, I'll just talk about these, are things that I think that obviously all of them are important, but I just want to make sure that, you know, this is kind of a glimpse of some of the things that we're working on, and we're hoping that obviously everybody joins us in, you know, in maturing these projects and so on. So, okay. To start with, we do feel that everything is really grounded in the data. So if you look at all of these statistics, whether it's the 50 billion or 200 billion, but we know that there is going to be billions and billions of devices and billions of connected sensors. And all of these are what differentiates these from just being a dumb embedded device, is that they're connected and they compute. And they generate lots and lots of data. If you look at a connected plane, at a smart hospital, at, you know, an autonomous driving system, whether it's a car or a drone, it generates just a massive amount of data. And that data needs to, that data is kind of, is almost the center of this entire structure, where, you know, it needs to be processed, it needs to be transmitted, it needs to be acted on in some form or another. It needs to be stored in most cases, and that is what is driving, you know, the need for this completely different infrastructure that you know, that all of us are working on, and all of these communities that, you know, that's been talked about so far. And obviously, not all of that compute can happen, as, you know, in just thinking back only 5 years ago, that, oh, all of it happens on, you know, on the data center. That's just not That's just not how it works. The amount of data and the amount of compute that needs to happen forces things to go out to the edge. And this is really an important difference between today's world and only 5 years ago, when those connected those connected devices that can really compute really were not much into existence. And these things, this type of computing and this type of infrastructure really will transform economy. So if you look at, like, there is a bunch of examples here. You can take, I think the best example I heard the other day is about cars, just updating software in cars. So just creating the structure and figuring out how to safely and securely do an over-the-air upgrade for the complex, like a software-defined cockpit in cars of like 2-3 years down the road. That by itself would save $35 billion for the car industry. Imagine, we're talking about just one, almost like it's an afterthought, that would save this amount of money. So this is the value of that software and all of these things that we talk about. It is really, really important because it will transform the economy, and it will transform where companies are able to spend their money and where they're able to spend on. And this is, from car to cloud. This is, this is the classic example, because it almost, the car thing and autonomous computing in general just really encompasses almost every aspect of this, from the need for the cloud and what the cloud needs to do, and how devices connected, how devices connect to a device, how devices connect to a cloud, the safety critical systems that are needed, the network infrastructure, whether it's 5G and so on, that needs to get set up. So all of these things get encapsulated, almost like one engineer describes it always as like, look, the car itself really becomes, it's an edge device, but it's also in of itself is a data center that's just on wheels. Okay, so the challenges of edge computing, and these are like, you can go down the list of like what, whether it's orchestration, containers, databases, functional safety, and I'll talk about a few of the projects that we're working on in those areas. But that list of things that we need to work on is actually quite long. And so let me just give you examples, just run really quickly in the couple of minutes on things we're working on. Clear containers. So containers are great. And what's so great about containers is like they're fast, they're quick, you can do things like really, really quickly, you can bring up an app, kill the app, like microseconds, works great. Virtual machines are great. Virtual machines are very, very secure, but also, they're a bit slow. So with the clear containers, what we try to do, which is a perfect, is a perfect example of things that we absolutely would need on the edge, is to bring in the security features of virtualization of things like the VT instruction set, and make that behave and act like a container. The speed of a container, the being able to tear it up and tear it down, and so on. Open source on, I think, on clearlinux.org now. We're still, a lot of these projects, by the way, kind of starts organically, and we're still now in the process of trying to figure out, okay, like where should we open source this project? Where should it go? And so on. Great, just like a lot of people who participate in them right now. And this is one of the things that we, as I talk about these, if any of you have ideas in terms of like, hey, how can we, where should this project be? How should we govern it? And so on, we're completely open to all of those discussions. The lightweight orchestrator, aka Chow, as the engineers call it. So this was envisioned initially as a super lightweight Orchestrator that is very, very, very fast. Performance was very important. But the other thing that was also super important to us in Chow is that it is secure, and it is it requires very little intervention for it to come up. So it's what we call zero configuration. And so this is another project that we have up there. Functional safety. So, and in this regard, we're talking specifically about safety critical Linux. And by the way, we completely invented this term. We have no idea if this is, I don't think there is a project now. We've done a lot of work on it. There is a good understanding of what a safety critical system is, but all of that has been centered around microcontrollers. So like, yeah, sure, you can take a microcontroller, you can put on it, a system like VxWorks or like a real, like very, very small, almost like a loop operating system, and make it, functionally safe and pass functional safety certification. Can you do that on an industry type strength operating system, which is what is needed in order to support all the use cases that everybody talks about? You cannot just put any operating system on a plane or in a car that actually does things autonomously without having to comprehend this. So very exciting projects that will need to figure out, we collectively need to figure out how to do it and so on. Time-sensitive networking, again, same, I mean, the concept is probably all of you are familiar with it. It's just like on an end system, you do need to be able to have the real-time properties of but over the network. So I'm out of time, so I'll finish with this slides, end-to-end solutions. So this is really, really important. And this is why, I personally and all of us at Intel were so excited when the OpenStack Foundation kicked off, this is that for the first time, we will be talking about end-to-end solutions. Solutions like incorporating both the data center and the devices and the network in between and how they connect, because these things really do need to comprehend. A device needs to figure out how to connect to the cloud, and device need to figure out how to device-to-device interconnect, and we have multiple projects around all of those type of areas. But all of these things need to get figured out. So thank you very much, and thanks for the invitation, and thanks for your listening.